Welcome to the very first instructional video here for this class, Math for Elementary Teachers. This is so exciting. Just to give you a little overview to start how this will generally work, I'm going to be recording these videos for each section to correspond with sections in the textbook. Depending on the length of the section, I may even break it up into multiple videos just so you don't have to sit for one video for an hour and a half. I'll try to break them up into smaller chunks. But you do need to treat these as a lecture you would be getting in class. I'll try to make them as interesting as possible. But it is important that as you're watching these, you again treat it as if you are sitting in class and I'm in front of the class lecturing at a whiteboard, wandering out around the room. Put yourself in that same environment, free from distractions. Have notes, have paper, whatever you need to do to stay organized in the space while you're doing this. I recently went through a doctoral program, and a lot of it was online, and I had to do the same thing. And it was really important to me when I started that program to clear a space in my house desk where I was only going to be working on that stuff, right? So all my stuff could be organized while I did it. I found that incredibly helpful because I had to watch videos, I had to be in Zoom sessions, and I had to take notes. And so again, clear out that space. You're going to have to be doing stuff as we go through these videos as well. You'll notice I'm looking around a lot. My own space has camera, screen, second screen, a board that I write on here, which projects to the notes on the screen. I have my own notes, and so there's lots of stuff going on here. So if I'm not always looking at the camera itself, that's why. But I will try to address the camera as much as possible. So let's get started. This very first video in this first section is 1.1. Chapter 1 is problem solving, and so chapter part 1.1 is an introduction to problem solving. And what I'll do here is I'm going to share this, right? So you can see our note page. So a lot of the times I will be kind of copying and pasting text also, so you don't have to look at my messy handwriting. But problem solving is a core idea of mathematics. It's all about making sense of problems and also persevering in solving them. We want to be and we want to teach active, engaged learners. We want to seek solutions through research, through questioning, and not just jumping straight into answers, because that tends to be a default that a lot of people like to do. And so we're going to slow down. Just to give you a little overview here of what we'll be doing in this section. We'll focus, I'll try to do this as much as possible, where I connect what we're doing in this class to teaching and learning, particularly at the elementary level. This class is not a teaching methods class. You're not going to learn how to be teachers in this class. This class is about learning foundational skills that it takes to be an elementary teacher, foundational mathematical skills. To be a good math teacher, to be a good teacher, you have to have a deep rooted understanding of the work, of the concepts. And the best way for you to do that is to think about how your own students will think through problems. And the best way to do that is to do them yourself, right? So I'll try to make some connections to teaching and learning as we go through different chapters. We're going to talk about what problem solving is, conjectures, what those are. We'll talk about Polya's 4-step process to solving problems. This is sort of a process that's been adopted as the way to solve problems. And then we're going to look at multiple strategies to solve problems. So I want to start with this connection to teaching and learning. You may or may not have heard of the Common Core. Some people just talk about Common Core math. Common Core standards for mathematical practice. So there is a website, a link that I will also provide here and in our Blackboard class, if you care to look at the Common Core standards. These were adopted a number of years ago across the country. They grew from standards set by the National Council of Teachers of Mathematics. So that's a national organization, the National Council of Teachers of Mathematics. I've been a member of that organization myself. And it's sort of it's not necessarily a governing body, but it's a body of mathematicians and teachers who've developed and discussed and shared ideas about what should students be able to do at each grade, right? Each grade level throughout their elementary and middle school and high school years, but also just habits of mind that all mathematicians should be able to do. And so they've got what they call their in the Common Core, the standards for mathematical practice. And I'm going to do a little copy and pasting of this as well. So the standards of mathematical practice are, let me enlarge this, are 8 habits of mind and attitudes that mathematically proficient students attain from discussions, explorations, contemplation, and involvement in problem solving, which is what we're talking about here today. So 8 habits of mind, 8 things. And the very first one of them, the very first practice standard is this. I gotta find a better way to do this. Let's do this. The very first practice standard is make sense of problems and persevere in solving them. I mentioned some of that in the introduction here. Make sense of problems. See a problem, try to make sense of what it's all about, but then also solve the problem and persevere, right? Math is hard. Mathematical thinking is challenging. And so it takes perseverance, right? It takes fighting through the struggles and frustrations. There's a quote. I'm not going to do this a lot, but I really think that this quote here is important. And I'm going to ask you to do something with this as well. So this quote is related to that standard, right? That standard of practice, making sense of problems. And so I would just pause and maybe read this. Pause, read this paragraph, and sort of internalize it. I'll read it out loud too. Normally, I won't do this. Mathematically proficient students start by explaining to themselves the meaning of a problem and looking for entry points to its solution. They analyze given constraints, relationships, and goals. They make conjectures about the form and meaning of the solution and plan a solution pathway rather than simply jumping into a solution attempt. Younger students, elementary students, might rely on using concrete objects or pictures, like your manipulatives that you're going to be using, to help conceptualize and solve a problem. Mathematically proficient students check their answers to problems using a different method, and they continually ask themselves, does this make sense? Does this make sense? That's a lot, right? There's a lot going on there. But that's what it means to be a mathematically proficient student. Nowhere in there, nowhere in that statement does it say, get the right answers. Mathematics is often viewed as just a way to get numerical answers to stuff. And it is not. That's the change in thinking that the Common Core is trying to facilitate. A change in thinking about what it means to do math and learn math. And it's about mathematical thinking, not just getting the right answers. So to help illustrate this, And to kind of put a little bit of an end on this very first video, I've got an activity that I want you to do. Now you can do this in two ways. It's the called the frog jumping activity. And I'm going to be having a link in Blackboard to this that you can go right to. Let's do it like this. You can go to that website that you see there to pull up this activity. And the rules to it, I'm going to paste these rules here to this game. What you'll see is, and I'm going to draw a little picture here to start. And so I'm going to do 1, 2, 3, and I'm going to do a different color. Let's go blue. 1, 2, 3, and then I'm going to just draw a little grid. So now you can see why I like to copy and paste some of the text. Messy writing. So you're going to have a little grid here, and there's going to be one blank space, and there's 3 green tiles or frogs on the left and 3 blue ones on the right. And you can, if you follow those rules, the left set of counters, these green ones, can only move to the right. The ones on the right can only move to the left. And they can only move one space in their direction. They can't go backward. They can only move one space at a time unless they're jumping another frog, and then they can go 2. And the puzzle is solved when the 2 sets of counters have switched positions. So when these 3 blue ones get to over here and these 3 green ones get to over there. And you'll see that if you go to that site. Let me show you what it looks like directly on the site. It looks like this. They actually look like frogs. And so you can change the number of frogs in the puzzle if you just want to see it with 1 frog on either side, or 2 or 3, or you can even go 4 or 5. And what I would like you to do as you try this is, let me go back to my notes, is try it with different number of frogs on each side. See if you can determine the minimum number of moves that it takes to do that. But then most importantly, the most important part of this exercise is not the actual solution. It's not solving it. I want you to monitor your own thinking as you do this. This is called metacognition. When you're thinking about something, but then when you're also observing your own thinking, you're thinking about your own thinking. Monitor your own thinking. Notice what strategies you're doing. Notice where you get stuck. Notice the mistakes you're making. And then go back to this paragraph that I had up here earlier from the Common Core Standards. And notice how I had some of these underlined actions, okay? Notice which ones you're actually using and not. And then consider what tools you've used or you have that helped you to persevere in solving that problem. And so there's not really a conclusion to this other than I want you to try it, monitor your own thinking, and just make observations about, again, how you used these actions here as you went through that process. I'm going to stop sharing, give you time to do that, and this will be the end of the first video. We'll pick up with the rest of the section, or the next part of the section on the next video.